In this video, we'll describe cogeneration and calculate utilization factor for a vapor power cycle with process heat. Okay, that's kind of a mouthful, but that's what we combined lesson objectives 64 and 65. But I think they're pretty short, so it shouldn't be too bad. So cogeneration, what is it? Well, cogeneration is the production of more than one useful form of energy output from a power cycle. So it's a little bit easier. Let's show it on the Rankine cycle. So what we've done is we had our standard power cycle with our pump, our condenser, our steam generator, our turbine, produces some output. But then we've said, hey, we're going to add this other system called process heat. Okay, and it shows up right here after the turbine. So before we go to the condenser, where we're going to just be getting rid of all of this heat, we're going to say, what about some of that heat that we might still be able to use to make use of? So it's the energy at the turbine exit applied to useful purpose. That's what process heat is. And so we take that process heat and we can apply it in just different examples. We could use it for chemical processing. We could use it for heating, air conditioning systems. So a lot of times power plant, the actual heating of the power plant will come from the process heat from the power plant cycle. So they'll just say, why actually use electricity to do heating? Hey, we've got this extra heat in the building anyway, so let's just make use of that. So it's not going to affect your thermal efficiency, because thermal efficiency is just the required that heat coming in over the work that you get out, the output or the total work, the net work, divided by the heat that comes in. But we do have this other performance metric called utilization factor. So utilization factor says, hey, things might be more than just, I might want more than just power coming out of the system. What do I get usefulness out of here? So utilization factor looks for useful output over required output. So before we said desired and required, and here we still have this. Our desired or useful output over our required output. Well, in this case, we have that net work and that useful heat. So we're going to subtract it here because the heat is leaving, so it's going to be negative. But we want to say that that's a good thing that the heat is leaving, because we're going to make use of it. So we're going to subtract that useful heat and divide it by that heat transfer coming in. And that's going to be our equation for utilization factor. So cogeneration, just making use of that heat that would normally go to waste, and it's the metric of how much utilization, how much efficiency we get out of using that process heat comes from our utilization factor.